Let's work through a demo on working on designing and analyzing a study where you design your own data collection. I'm basing this demo on a real situation that I was helping with a few years ago, but I've anonymized it a bit, generated some simulated data to use for confidentiality reasons. So let's say a chemistry professor wants to know what's the best temperature and acidity or pH to run a particular reaction at to get maximum yield. Yield is kind of the percent of total product that you expect to get. And this professor maybe did a bunch of trials at various combinations of temperature and pH. You might have heard that sometimes you should only change one thing at a time when doing statistics or experiments. And that's true at kind of the Stat 101 level. But there are some methods that you might learn in a higher level math or stat class that let you do more complicated things. And we're kind of preview some of those. I'll be using the AI tool juliusdate.ai. I'm not saying it's the best tool out there. It's just the one that I have the most experience with. They're not paying me to be mentioned. In fact, I'm paying them because I ran out of prompts on their free tier, so I subscribed to their cheapest paid plan. I uploaded a spreadsheet of pretend data to Julius. So it was an Excel sheet that had like the start time of each experiment, the pH that it was run at, the temperature it was run at, and the yield that it came up with. And just to make clear that this is not real data, I have a column here that says, what type of data is this? It's pretend real. And there's also this block. So there's like block one and then block two. And within a block, every combination of temperature and pH is done once. And then in block two, again, every combination of temperature and pH is done once. So let's see the Julius session. Um, let's go. Okay, so I uploaded the file and I said, I uploaded this file. What combination of pH and temperature will give me the best yield when I conduct this experiment in the future? So it goes and writes a bunch of Python, and boy, is it tempting to just trust the Python that it wrote. Really, we should be reading through it and seeing is this doing reasonable things. Maybe you don't have to understand every single command, but you should be able to get the general feel for this. So, this is loading up the Excel file that was defined here, talking about what sheet names are there. And it gives us a little explanation, and we should be reading that. We can show more of what's going on here. And then it actually had some kind of error. And then hopefully it went and tried to fix things. And then it's importing some libraries that it needs here, um, describing the data frame. A data frame in Python is basically a spreadsheet. It has rows and columns, except in a spreadsheet file, you can type in formulas. In a data frame, it's just data, and the formulas happen in other lines of the code. Um, so here it's making a heat map of mean yields. So let's go see that. Um, and so it's saying for various temperatures on the x-axis and various pHs on the y-axis, what was the mean yield? And it's got a color scale here. Higher yield is better. So this yellowish color is the best among the data we have. So that gives us a good hint, right? Um, so then let's go back to the code. So it gives us a summary there. Yeah, it says that's the top observed yield in the data set, but that doesn't mean that that's the actual best thing to run it at because there was probably some randomness in the data. Maybe if we ran the whole thing again, we would have gotten a different answer. Or maybe we didn't even try the best possible combination. Maybe we should have tried a warmer temperature or a colder temperature or a higher pH or a lower pH. Maybe this data can tell us something about that. Um, so we've got what's interesting here, it called the sweet spot. And then I used Gemini AI later and it also mentioned the sweet spot, but I don't think it's the same LLM. Um, then I told it, please plot X equals temperature and Y equals yield with different colors for the different pH values used. And it shows me the code it used to plot it, which all looked reasonable to me. And then let's look at the graph. And this surprised me. See if you notice anything interesting about it. what I noticed is this green line seems to be splitting the difference between the orange dots, and this blue line seems to be splitting the difference between the blue dots, and this orange line seems to be splitting the difference between the green dots. So I said, the green line seems to go with the orange dots. Please make it all consistent. And so it thought about it in its own way, told us, oh, one of them was treated as categories and the other is numeric. And so it assigned the colors differently. So now it found a way to fix it. So got to make sure that the orange goes with the orange now, and that seems to be working. So we seem to be seeing like at lower temperatures, the yields seem to be higher. And at the low pH, more acidic, the yield seems to be lower. So that's giving us some ideas. And then I said, well, make a similar plot, but with X as pH and the color as temperature, kind of taking different slices. And it gave us that, and the colors seem to match. So that's good. And then I said, please make a 3D plot, hopefully one I can spin using my mouse. So it put some code here and it gave me a file I could download. So let's go download that and play with it. So it's got temperature and pH on kind of the flat plane, and then the yield as the z variable, the response variable. And it's fitted some kind of surface there. It's we'd have to think, is that using straight lines, or is there a bit of a curve there? Or is that just kind of a accident of how we're viewing it? So it's a pretty nice feature. It's got the color coding for the higher yields and stuff. I guess we don't really need the color coding for the higher yields because we explicitly have a yield axis, but I guess it was being nice. Um, uh, and then I told it to go look at potential block effects. Like um, what if we remade whatever chemicals we need in between block one and block two, but we did it differently for block two? And maybe all our answers ended up higher for block two or ended up lower. That would be block effects. It's something we should examine. The plots got really complicated here, so let's not worry about them for now. If you're curious, let me know and we can talk through them. But basically, not much difference here compared to the confidence intervals. Um, so don't worry about that. And then I said, please compute block two minus block one at each combination of pH and temperature. Because then if block two minus block one tended to be positive, that would mean block two was usually higher yield than block one for each combination of pH and temperature. And then it gave us this heat map. And we see some strongly negative numbers there, some strongly positive. Doesn't seem to be a pattern, so it's probably not worth worrying about. Um, and then I said, please fit a response surface model without block effects. So that's saying, how does the yield respond to the pH and temperature? So kind of like that 3D thing, fit a surface to that. And it went and did it. Let's see if we can see where it's doing that. So it's saying it's using some polynomials. So not just linear regression because we want a bit of a curve to it, because we think it'll top out somewhere, and a linear function can't top out somewhere, but we need like parabolas to be able to top out somewhere. Um, so it fitted like intercept plus linear term in pH plus linear term in temperature. Plus, this is an interaction of pH and temperature. Maybe the pH matters differently at different temperatures. Plus something about pH squared. So that's our parabola part for pH, and something about temperature squared. Um, so then it gives us all those coefficients that it estimated here. It's hard to interpret those, but it does point out that the coefficient on the squared terms is negative, so we got upside down parabolas rather than right side up parabolas, which is what we expect. It tells us we got an R squared of 0.77. Don't worry if you don't know what that is. And does some plots that we could spend more time investigating. Then it suggested a contour plot. So that's kind of like a smushed 3D plot. So I said, yes, that's a good idea. And it said, okay, here we're predicting higher yields in the yellows and lower yields in the blues. And here's the points that we tried the experiment at. And this seems to be the best, the thing that gives the highest predicted yield, at least within the set of experiments we did. Maybe we'd lower the pH a little bit, but we're on the border there. And then I said, expand the range of pH and temperature so we can see where the model predicts the true optimum is. And it says, okay, here's the combinations of pH and temperature we tried, but our model predicts the best combination would actually be out here. So then that can motivate us to go back to doing more experiments out in that range, see if we can get the yield even higher. Um, and I had it create a 3D surface plot. So here's the upside down parabolas kind of thing, and saying where the optimum, predicted optimum is compared to all of our data points that we actually took there. So this is the kind of stuff that I could have done in Python if I had devoted a whole day to it, but this only took me probably less than 20 minutes in Julius AI. Um, so that's that. And so once you get once you're done with a chat or whatever with Julius, it'd be good to save it. There is this generate analysis report thing, which it might be good in some cases, but it doesn't show the prompts you gave and the code. It's more a summary of the whole thing. So what I'm asking you to do for your homework is use these three dots here and say download as docx, or that's a Microsoft Word file, and then upload that as part of your homework submission. Okay, so we just talked about that. Um, I also tried the same thing in Gemini. As an EMU student, you have access to Gemini. You should sign in with your EMU account. Well, here's the analysis report from Julius. Um, so here I am in Gemini. I uploaded the file. I asked it what combination of temperature and pressure will give me the temperature and pH will give me the best yield. And somehow it didn't manage to see the Excel file. So it just gave me generic stuff about reactions and yield. So I said, use the Excel file that I attached to the previous prompt. You write code, and it actually gives me these little show code things. So it doesn't default to showing you snippets like Julius does, but you can go at least read the code it generated, or you could copy paste it to your own machine to run it locally. I'm not expecting you to do that for this homework. And it gives us a little summary of what it saw in the Excel file, and it generated a heat map. Let's see. And then I told it to generate, I basically gave it the same prompts I gave Julius. It's giving me mostly the same answers, slightly different style to the graphs, but that's okay. And then I said, please make a 3D plot. And it gave me something that I could try to download, but it didn't work. And so I complained, and it said, well, I'll just give you a few different rotations of it. So yeah, you can try Gemini, especially if you run out of prompts on the free tier of Julius. Oh, and at the end here, it said you reached your thinking model limit. Your responses will use other models, not as fancy, until a particular date and time. So with Julius, once you run out of prompts on the free tier, it doesn't tell you you can use more at a certain time. At least it didn't tell me. I just had to do the paid upgrade. So here, at least you can keep going if you just wait. All right. I think that's all I wanted for this video. Yep, and we'll do another one next.